Unit testing is something that has proven its value time and time again in not only web development but software development in general, no matter what language or platform you like to use. The ability to unit test was one of the primary drivers behind the MVC pattern. Now, the MVC pattern, as you may or may not know, predates the Microsoft MVC framework by quite some time. The Java community was already using the MVC framework. Other languages and technologies were using variations of the MVC pattern. The MVC pattern, the idea of separating your application's functionality into models, views, and controllers, is something that has been around long before the MVC framework that Microsoft put out. Microsoft's framework is just a way of implementing or embodying this pattern. And one of the primary drivers behind the pattern is the ability to unit test. When your UI code and your data and your behaviors are all tied together, it's almost impossible to unit test them. And so testability was a huge driver in why we might even want to code in an MVC fashion to begin with. If you're not doing unit testing, you might want to sit back and ask yourself why you're bothering to use the MVC framework at all. Obviously, I'm a huge proponent of the MVC framework. I don't want to go back to web forms ever again if I can help it. But one of the reasons I love it so much is because of the clear separation of concerns and how testable it is. So if you're not doing unit testing, you are missing out on a huge, huge value that the MVC framework can bring you. A unit test tests specific segment of code behavior apart from any dependencies. Now, this is what separates a unit test from an integration test. A lot of times when people write unit tests, they call it unit tests, but it's really an integration test because their code actually hits the database and does some other stuff. A unit test targets one specific segment of code, usually it's a specific method, and it tests that unit of code apart from any of its dependencies. So it fakes out the database, it fakes out every other object that this unit of code needs just to make sure this specific piece of code is doing what we expect. A unit test is also usually restricted to a specific application layer. So if I'm writing a unit test and I'm testing a controller, then I don't want that unit test to reach into the services layer or the repository layer or data access or anything like that. I want the unit test to stay at the level of the controller. So generally speaking, your unit tests are typically restricted to the layer that you're in. You want to mock out or fake out dependencies on the lower layers, which, if you've been coding to interfaces or coding to abstractions in a nice decoupled way, should be relatively easy. But that's one of the hallmarks of the unit test, is that it does not drill down, it does not test functionality that depends on concrete implementations of the functionality further down. So if I run a unit test for my controller and something actually happens for real in the database, or a service for real actually gets called, then I'm not really unit testing anymore. Now I'm testing several links in the chain. It's looking more like an integration test. So a unit test is really about testing this code in isolation. And it's very important not only from a design standpoint, but it's also very important from a debugging, regression, and functionality standpoint. We want to make sure that changes to code don't break the methods that we wrote. And we want to make sure that our methods are nice and decoupled so that we can make changes to them without those changes impacting other layers in the application. So it's a great tool, it's a great value, it's a great risk reduction tool as well as a great design tool. So if you haven't gotten into unit testing or test-driven development, I highly recommend that you take a look at it. I don't know if you've ever noticed this or not, but it is really easy to start fights in a group of geeks. It's really true. If you are in a group of them, just try to start a conversation on which is better, Star Trek or Star Wars, or was J.R.R. Tolkien really a good writer? And inevitably you're going to get some pretty heated conversations. Well, Unit testing and your favorite unit test framework tends to do that for geeks who happen to be software developers. So I want to start at the beginning by saying that there are tons of unit test frameworks out there. MS Test is a very popular one with people who use Visual Studio. NUnit is another one. I used MBUnit for a long time myself. I really liked that one. There's all kinds of unit test frameworks out there and different ways to use them. So if I don't show your favorite one today, please don't get mad. What's really more important is that you understand the principles behind the way unit testing works so you can unit test your MVC applications. And then if you understand the principles, then you can use whatever tool you want. So just keep that in mind as we go. What I've got here is a project called Unit Test Demo, and this is simply the default MVC project. If you add a new MVC4 project to your solution and you choose the internet template, then it generates this default web application, which is pretty familiar to many people who've worked in MVC. Okay, so many of you have probably seen this page before, perhaps many times. It's just the default MVC page. And I'm going to write some unit tests. Now, generally speaking, I like to write my unit tests before I write my code. That's what we call test-driven development. I like writing out my tests and the way I expect the code to behave because it helps me design my classes and the methods and the APIs and everything, and it saves me a lot of time that way. But in this case, for demonstration purposes, I'm just going to write the unit tests for code that already exists, because this isn't a presentation on how to code, it's a presentation on how to do unit tests. But I would strongly encourage you to first of all write unit tests, and to secondly to work on writing your unit tests first, and I'll kind of talk about how you might do that before you write the code that makes the test pass. But at least start writing them. There's still value in unit tests that are written after the fact, especially for regression testing. But I feel like you get most of your value when you write them first. Anyway, I like to keep mine in a separate project. I'm going to pick new project here. The reason I like to keep them in a separate project is that way it's easy for me to exclude them from the build, and there's a pretty clear division between my test classes and my actual classes. There's a few different ways you can go here when you go to add a new project. If you want to use MS Test, then going down here to Test and selecting Unit Test Project is probably your best way to go. That way Visual Studio will go ahead and configure MS Test for you and install all the DLLs, and you're set. For just about any other unit testing framework though, you're going to want to use the class library project. So that's what I'm going to use because I'm going to be using MSpec today. Keep in mind that what you're going to see is pretty common in just about every unit testing framework. So I'm going to call this unit test demo .tests.unit, just so I can keep that distinct from my integration tests as well. I like to have a lot of tests with my applications. Okay, and I'm going to use NuGet. I'm going to click up here on the project, say Manage NuGet Practices, and I'm going to look for machine.specifications, or MSpec. It'd help if I looked for it online instead of in installed packages. Okay, so here's machine.specifications. I also like to use mock objects for my dependencies, and so you'll see me install machine.fakes and machine.fakes over my favorite mock object framework. So I'm actually going to come down here and choose machine.fakes.fakeiteasy. What that does is it installs, well, machine.fakes and fakeiteasy. And fakeiteasy is my favorite framework for making mock objects. And then I'm going to need machine specs as well, obviously. So let me go ahead and install machine specifications. And then machine fakes. And it looks like looks like even though it's not listed, mspec was a dependency here, so you can probably get away just by installing machine.fakes.fakeIteasy, and it'll pull everything else in. Okay, so I've got my references, and now I'm ready to roll. So first thing I want to do is create my first unit test. Now, for this particular web application, the functionality is not real amazing, so I'm going to test going to the About page. At least we'll start that way, and we'll kind of see how things go. So what I'm going to do is right-click, I'm going to say Add Class, and you know, what's the behavior I'm trying to test, and I'm going to choose when the controller. Actually, let me organize them like this. This will show you a little bit more closely how I like to work as opposed to just a random demo. I actually like to subdivide my unit tests by layers. So you know, I might have folders that look like this, and so I'm gonna go to the controller here, and that way I won't have to put controller in the name. That'll be great. And so I'm going to do something like when viewing the About view. This is going to be my test when viewing the About view. And the first thing I'm going to do is specify a subject. And my subject is going to be the actual thing that I'm testing. So in this case, I'm going to be testing, it looks like the home controller. And it's going to whine at me because I need the main project in there. So I'm just adding references to the project that I'm testing here. Okay, there it is, home controller. Okay, I want this to be with subject, not just subject. Okay, and this tells my class that the home controller is going to be the only real thing in this test. Everything else is going to be a fake. Now, as it turns out, our home controller has no dependencies. But like if, for instance, let's say I had something like this. So my home controller needed an instance of a user service, and I did something with it here. What mspec will do is it will automatically create a fake object for this. So this is great because if this happens to be like my data access code or whatnot, mspec will go ahead and create a fake one here. I don't have to mess with it, and that way it keeps me from actually hitting the database or actually hitting the service. As it turns out, I have no dependencies, so I'm good, but that's one of the reasons I like mspec, apart from another reason which I'm about to show you. The next thing is that MSpec follows, and most of your unit tests should follow, a arrange, act, assert pattern. Okay, so arrange is going to be what's the stuff that needs to be set up in order for this test to run. Act is going to be what's the specific method or call or whatever that I'm testing, and assert is going to be the things that should be true when this happens. Okay, so in MSpec, each of these guys has a specific syntax. I'm going to leave it like this. Okay, so the first thing is establish that. And now here's where I'm going to do any setup work. So any objects that may need to be set up, anything that needs to be instantiated, any specific fake data I want to use is going to go here. Now in this case, none of that needs to happen because I don't have any particular logic going on here except for the actual view. Okay, so I'm actually going to comment this out, but I'll leave this in here just so you can see what it looks like. Okay, let me put in some notes here. Arrange is the setup. Act is actual method call. Assert is the stuff. Okay, and the syntax here is because. Okay, so my subject is the home controller, and I'm testing its about method. Okay. Now, this will just invoke the about method, but you'll notice that about returns an action result, and I kind of want to check some stuff about that, so I'm actually going to do this. I'm actually going to set up a private variable. And I'm going to set it to equal the subject. Now this is going to give me a little grief because technically controllers return an action result. It's just you and I know it's going to be cast to a view. So let's see, let me make that guy static, and then he's going to complain because he wants a view result. There we go. Okay. Now we do a check. I'm going to say it should return a view. Result should not be null. And this is where I put in all my tests. It should have the correct name. Result dot view name should be, let's see, I think what I actually want is to check for equality. So I want should equal . Okay, and the coloring's kind of doing a number of us on here, so let me highlight this just to make it a little bit clearer. So because of the subject firing the about method, then it should return a view. So I'm checking that it's not null, and I'm checking that the view name should equal about. So when I run these guys, okay, it did return a view, but I failed on it should have the correct name. So it said it expected about, but it was blank. Well, why is that? Well, when I come back to Home Controller and I look, I see that I'm using the implicit name. I'm not actually specifying a name here. So I can either change my test and say the name should be empty, or I can let the test drive my design and say, actually, you know what? I'd like to specify the view name. I wouldn't like to let it just be implicit. I build that, rerun that test, and now it's passing. You can see taking the time to put in the underscores and things like that really helps when we are troubleshooting, because now I can look and see exactly what passed and what failed.